second last talk is by Cris Ewing, who is going to tell us about debugging Pytest and Django. Please make him welcome.
Hello, Python folk. So I came here today to tell you a story about debugging. And I tell this story because it's honestly a good tale. But also, I found that when I started out in my software career, having somebody tell me, just open PDB and debug, wasn't particularly effective. I learned the most about debugging by listening to the stories that other people told about the hunts that they went on. And I'm hoping that you'll find some interesting lessons in the narrative of my pain from this particular experience. I think it's also important that we tell these kinds of stories to each other because oftentimes we think about other developers as if they were this guy. Supremely confident, tough, absolutely capable, and totally skilled in his craft, where in reality, most of us are a lot more like this guy. We sort of bumble around. Sometimes we manage to find the rabbit, but it's as much by chance as by skill. There's a couple of lessons that I'm hoping specifically that you'll take away from this talk. The first one, of course, is that even for the experienced, print is, in fact, a useful debugging tool and can get you out of a lot of jams. Logging can also be a really powerful tool, especially if you're doing it inside and outside Python when you're dealing with systems that are correlated with each other. The inspect module, which we've heard about this weekend, which I was kind of surprised by, can also help you to get a lot of context about the work that you're doing in the places where it's happening. There's a truism about debugging, which is that where you see the bug is not often actually where the bug happened, and that's another lesson we'll learn today. Finally, I want you to trust your instincts, to learn to understand that when you feel like you might be looking in the wrong place, you probably are looking in the wrong place, and you should move your head elsewhere. And the last lesson, of course, is that no matter what ends up happening, reading the manual is, in fact, a really great way of figuring out how to solve problems. All right. With all of that out of the way, let's go ahead and get started. My story, of course, as explained by the title, is about using Pytest in Django when testing a Django application. And of course, this begs the question, why would you do this? Django has its own perfectly capable test runner. Why would you want to introduce something else and add a layer of complexity to it? And you know, honestly, this isn't the place for me to go into details. Suffice it to say, our team really enjoys using Pytest and the features that it gives us, and so we do. And if you're going to use Pytest as well, you should know that there's a really nice tool, a plugin for Pytest that exists out there that makes this sort of work nice. If you're going to follow this path, you should absolutely use Pytest Django, because with it, testing Django with Pytest is simple and easy, except, of course, when it's not. So I was working on a problem, I was developing a new feature, I ran my tests, and bam, this traceback showed up. And like any good developer does, when I see a traceback pop up, the first thing I did was I looked at the bottom and noticed that it was telling me that there was a connection still open to my database. The top of the traceback explained to me that that was happening when we were trying to tear down the database at the end of the test run. So this is the starting point for my hunt. But before I continue any further, I want to talk for just a second about this line here, where it says that the above exception was the direct cause of the following exception. This results from a change that Django made in an exception wrapper class that used to look like this. So Django, like a lot of other framework code, creates a wrapper around exceptions so that when an exception is raised from some plugin, like a database interface or something like that, it gets aliased into a Django core exception. This allows integrators, when they're working with the Django system, to just look at Django exceptions and not have to worry about what other kinds of databases their users might be using. I got the magical floor thing. And it came back. Good, I'm going to stop moving around and just plant my feet. So this is a great idea, right? It allows you to listen only for the exceptions that are coming from the framework that you're using and not worry about the plugins underneath you. But the side effect that this can cause is that the original exceptions get lost. And what you end up seeing is the location where the exception was aliased. This can hide the original intent of the exception. Well, Django updated their wrapper code to go from this to this. And that's a pattern that you'll see all over the place, where you raise a new exception from an old exception. And what that is explicit exception chaining. Now, this is something that's been around for quite a while in Python 3, and they're really probably shouldn't be much of a reason to talk about it, except that I often end up meeting developers who've never really seen it before or engaged with it before and wonder where that, this was the cause of that phrase comes from. So hopefully that will help you out at some point in time. Back to the story. We've got a connection hanging open. The connection is remaining open at the end when we're trying to tear down the database. And of course, the worst part about this particular bug was that it happened only some of the time. Occasionally, it would work. Other times, not at all. And I hate these kinds of bugs because it means that there's something random involved, right? And trying to find randomness and trying to hit the right moment when things go bad is really difficult to do. Now, I'm a believer that there is strength in numbers, which of course is just the optimist's way of saying that misery loves company. So I went to the classic place that everyone does and looked for other people who had felt the same pain that I was currently feeling. And I found plenty of examples. There were lots of issues that were open in GitHub, that were referenced in Stack Overflow, that talked about running tests and having these connections being dangling at the end when using Pytest and Django. That was fantastic, but most of them had to do with concurrency, running in threads or subprocesses or things like that, and that wasn't something that I was doing, which led me to feel like maybe this isn't really the actual cause to my problem. I did find a number of blog posts about this specific issue that recommended a brute force approach to the issue. I even found a bug report down inside Pytest Django's repo that suggested adding a Pytest fixture to just terminate any dangling connections that were left open at the end of your test run, Terminator style. Now, I'm not a believer in using a hammer where a pair of tweezers is going to be sufficient, but there was actually useful info in this particular post, namely the name of this table in Postgres, which I had never seen before or even been aware of. It was something that I had never known about. But what it does is track open connections to the database and the things that are going on inside your database while it's running. Using that table, I could at least try to find out what query was going on at the time when the database had this connection left open at the end of my run. I just needed to see this from inside Python somewhere. So I figure, if I print the rows in that table right where the database is about to be destroyed, I might be able to find out what queries are ongoing when it happens. But to do this, I'm going to need to find a good place down inside my code from which to do this printing. Now, there's a couple of criteria that I consider important when I'm looking for a good place to add logging statements. The first thing is that the location needs to be something that's called every time my problem happens. I don't want my failure to happen and not see the output that I was looking for. However, I also want to reduce the amount of noise that's present because of this printing or logging that I'm doing. So I want to try to find a spot where it's not going to be called too many times when my bug isn't happening. Finally, I need to look for a place in the code where the information that I'm trying to use or the tools that I need are going to be in scope already so that I don't need to do a lot of extra setup. I want to do the minimal amount of work that I can. And when I looked at my traceback, this was the frame that popped out at me. First, the location is clearly going to be called because it's right there in the traceback when the error happens. I know for sure that my printout is going to happen when the bug happens. Second, if you look below this line, you'll see that all of the names for the functions change from things like destroy database to execute. And execute is a pretty general statement that I'm imagining in my head probably means execute this query or that query or the other query or any query. And if I were to put print statements in there, I'd see them all the time. And I don't want to see them all the time. So I'm going to look in this frame. But you might ask me, why not look above this frame at that other destroy test database that exists? And the reason for this comes from a pattern that Django tends to follow, or at least that I've found that they follow, which is that they pair up public wrapper methods, things without that initial underscore, that do setup for methods and get the world sort of ready for the action to take place, with private actor methods that actually do the work that is implied by the name. So if I'm going to put my code somewhere where there's connections to the database, where actions are about to happen, I'm going to drop it into the private actor method because that seems like the likely place for me to be able to find my stuff. And when I went looking at this, I found that yes, indeed, there was a connection here. There is a cursor here. I can interact with it. But what is this cursor thing? It's not something that I've ever seen in Django before. It turns out that it's a part of a specification that exists in Python called the DB API 2. It's 2 because it's the second version of this thing. It's been around for a long time, and what it does is define an interface for Python interacting with relational databases. If you know about this tool and you understand the API that's there, then whatever tool you happen to be using, whatever database you happen to be using, if you find a connection, you know you can make a cursor with it. And if you find a cursor, you know you can execute functions and fetch rows and do things like that. The API will always be the same. Now, I first learned about this tool when I was trying to get a curriculum together to teach a course about interacting with databases in Python. You can learn about it too using the same source that I did, which is Doug Hellman's excellent Python Module of the Week blog, where he covers the standard implementation of this in Python's library called SQLite 3. All right, so I'm going to go into this function, and I'm going to add a little bit of DB API 2 magic to execute a select query that picks all the rows up from this table. Then I'm going to print all of those rows right there in the middle of this. And when I did that, on successful test runs, there was nothing, which is great. This is exactly what I'm expecting, right? The test succeeded, there's no queries left open, bang. And when I do failed test runs, this is what I see. This is excellent, right? I now have evidence that my theory about what's going on here is correct. There is, in fact, a query that's hanging open at the end of this work. But the problem is that rollback is kind of a generic query. It's used to undo any of the work that you've done in a transaction in a database. And transactions, especially when you're testing, are used all over the place. You use them to manage the queries that create database tables, the queries that put fixture data into those tables, and all of the queries that happen in individual tests so that things remain nicely isolated from each other. But which one of those situations is this one? I don't know yet. So I'm obviously going to have to dig just a little bit further. To do this, my next step was to go and look at the Postgres logs, because what I figure I can do is try to find out what query was the query that was being rolled back that the rollback never completed for. I don't know. This might help me out. It certainly seems reasonable. But in order to change logging for Postgres, I had to actually find my config file. I never remember where this stupid thing lives. And what I did was discover that there's this nice little command that you can run that will actually tell you where your config file is, so you don't have to remember in your head whether it's in etc or var or what the fuck ever. This is a good thing. I like it. So I found my file using this lovely little command, and I added a couple of lines to my postgresql.conf. The first two here turn logging on and tell the logs where to go. The second three lines tell me what I'm going to be logging, which is all of the statements that are executed in the database, as well as all connections and disconnections that happen. This next statement tells me that I also want to log how long things are taking, because I have a theory or a thought that maybe a really long query is hanging out beyond the point where it should, and something odd is going on there. And finally, I'm going to add a little bit of a prefix to the front of each one of my log lines to add some extra info about that line. Probably the most important part of this, though, is this little /n/t at the end, which is going to take the log itself and put it on the next line indented one tab space. And the reason that I like to do that when I'm doing things like printing out just a bunch of logs is that the formatting makes it a hell of a lot easier to scan all that information that's flying across my screen. Now, there are lots of options for the kinds of information that you can add to these prefixes, but the ones that I chose were the process ID, the session ID, the line number in that session, and then the start timestamp for the particular session. Those seemed like good things to me. I really just kind of grabbed them out of the hat. As it turned out, they were pretty useful. And then the last step was to go ahead and restart Postgres and then tail my logs using the tail utility and the -f flag. What that does is it lets you see the logs as they write in real time so that you can sort of follow along while the work in your database is happening. And once I did this and started my tests, good things began to happen. When I had successful test runs, I began to notice a pattern. There was a first connection that would open. This is numbered 70 here, and it would create the database and then immediately close right afterwards. The next thing that happened was that there would be a new connection that opened that set up the database and then managed all of the tests that happened. And finally, after that closed, there would be a third connection that would open where the database was actually dropped. And right there, just before that second connection closes, is a rollback query, which seems, at least theoretically, to correlate with the stuff I'm seeing in the logs. In failed test runs, I noticed a really similar pattern. We'd have this first connection that opens up, creates the database, and drops, and then a second connection, which is number 44 here. 43 is the first, 44 is the second. It gets used for database setup. And I can also, at the end of the log, see connection number 44 close, and number 46 open to drop, wait, 46? That's not a sequential number. And in the last pattern, there were sequential numbers. And when I looked for my rollback, I noticed that it was happening in connection number 45, and there was a number 45 that was left open at the end. But where did this thing come from? I had to find out the answer to this question. So I went looking into the middle of the log somewhere to try and find where that started. And bam, I found it. Here's the first query where connection number 45 gets opened. And right before that, there's a query being issued to do something that has to do with migrations. This seems like a clue. It's kind of funny. So here's the migrations query right here, and I'm thinking this is a clue. It's a place I can go look in my code. But now I really need to understand what's actually happening inside my code. I have some examples of things that are happening in a log, and those give me a kind of a sense of the temporality of the bug that I'm looking at. But I need to be able to correlate that stuff that I'm seeing in the logs with actual actions that are happening in the code to try and figure out at what point this weird, spurious connection gets opened. Let me take a break here for just a second so that we can talk about what we know at this point. First off, we know that there's an open connection that's preventing the database from being destroyed, and that the dangling request that's in that connection is a rollback query. We know that this open connection is created during database setup, and that the extra connection is opened before the tests actually run themselves, and that this extra connection seems to be related, at least in time, to migrations. Now, before we move on, I need to remind you that we're using Pytest in Django, which is sort of the whole point of this talk, and we need to understand a little bit of something about how Pytest works. Pytest uses fixtures to create the world that it wants your tests to run in. Let's imagine that we have some object named a foo, and we have a function called find a foo that is supposed to find one when one exists. So we write a test that says, assert that there is a truthy value that comes out of the find a foo function. In order to make this work, we can create a fixture called create a foo that actually makes one of these things happen, and then we can make the test actually depend on that fixture by passing the name of the fixture in as an argument to the test. Fixtures can even depend on other fixtures. Pytest, Django, uses a DB fixture to control access to the database. If you don't actually provide the DB fixture as a dependency for your test, you can't use the database at all, and an error is raised when you attempt to do so. This actually is kind of useful in that it lets you figure out when there are odd connections or queries happening against your database that you aren't aware of. It's pretty super. When I looked at this particular fixture, the DB one, I noticed that it was dependent on 3 other fixtures. Request is one that's provided by Pytest, and I don't need to pay much attention to it. The Django DB blocker one that's at the end there, that one is responsible for opening the connection to the database and allowing it to happen, or blocking that connection off. So I don't really need to pay attention to that either, because I know that the problem is happening in interactions. But the middle one there, that Django DB setup one, looks kind of useful to me. The name suggests that it has something to do with database setup, so I should probably dig in there. And when I did, I noticed that it imported and then executed a Django function called setupDatabases. This is great. It's a really smart idea for Pytest to do this because Django moves quickly. It changes from version to version, and by using Django's own code, Pytest Django doesn't have to keep up with the Joneses. It can just continue to call the API that Django itself provides. All right, so we now understand that Pytest uses this DB fixture, that the DB fixture calls through the Django DB setup one and into Django's own code, this setup databases function. That's the next place I'm going to go hunting. So when I looked into that function, I was trying to look for correlations with my logs, and I found that it calls something that's named create test database. This sounds like it has something to do with creating a test database, or maybe that create DB query that I see in my logs. So when I go to look there, I found that, yeah, there is in fact one of these private actor methods that does the query of creating the test database, and then immediately after, the connection is closed. And this correlates nicely with my failed log runs, where I see that connection open, the create database query go, and then the connection get closed again. Right after that, in the same function, you can see that we actually call a Django management command called migrate, right? And that migrate command correlates pretty nicely with those log statements that I was seeing that had to do with migrations, at least in my head they did. And right after that, connection number 45 got open. So maybe there's another line of code that happens quickly after this one does that is responsible for that extra connection. Let's go look. When I got down into that code, I found this down at the bottom, self.connection.ensure connection. And I thought, ha, this is good. This sounds like something that might check to make sure that there's a connection, and if there isn't one for some reason, open a new one up. There could be something that's accidentally closing a connection, and there's a new connection opening. I think I'm going to go look at that function. So I did. And my theory at this point is that sometimes this function gets executed and sometimes it doesn't. Or sometimes the connection inside there gets executed. This if self.connection is none, right? Sometimes that condition is true, sometimes it's false. So what I did to prove my theory here was to drop in a print statement with a little piece of text. And if I'm right about this, then every time I have a failed test run, I should see that. And every time I have a successful test run, I shouldn't. And lo and behold, when I ran the tests the first time, boom, there it was. And then I ran them a second time, and a third, and a fourth. Success or failure, lots of tests, no tests. It happened all the time. But really, this is my only thread, right? This is the place that I've gotten myself to. I have a choice. I can either give up at this point and just go back to using Django testing, or I can push on, intrepid as always, and try to figure out what's going on. I figured if this method is called all the time, whether the tests succeed or failed, maybe there's something in how I get to this code that changes. Maybe there's something in the path above me that's changing, that's causing this failure to happen. And so what I decided I needed was more visibility into the path that led me to this particular call. That's where I brought in the inspect module. It's made for this kind of work. It allows you to look at all kinds of internals for your code. You've already seen it this weekend. And the important part for me is that it lets you see the call stack that's going on. We've seen this multiple times this weekend, so I'm just going to zoom through it. You make a function call, and a frame pops on the stack. And when you make another function call, another frame pops on. And when you make another function call, another frame pops on, and so forth, right? We can zoom through that because we've done it 3 times this weekend already, which is great. Inspect provides this method called currentframe that lets you get access to a tuple of information about the frame that's at the top of the stack, the one that you want, the one that you're looking at right now. There's 6 pieces of information that you get. You get the frame object itself, the file name, the line number in the file where code is executing, the function name that you're sitting inside, the list of lines of context for your current call, and then the index of the current line within that context. So, I figured, let's go ahead and add some information to this particular function to see what has led me to this path. I'm going to import inspect, I'm going to get that current frame, and then I'm going to pass it to this other function called getOuterFrames, which lets you get the stack underneath the frame that you're looking at. So, when I do that and I look at the next frame, that should be the frame that contains the code that called this function right here. And this time, when I had successful runs, this is what I saw. And in failed runs, this is what I saw. Huh. There's an extra call there to this thing called getAutoCommit. Maybe there's something in that function that's conditional, that happens sometimes and not others. When I looked at the code, though, it was clear that that wasn't the case, which meant I was looking in the wrong place, and I needed to look a little bit further down. All right. This time, I did not make the same mistake I made the first time. Instead of just printing the next frame, I printed all of them. That way, I could see the full stack that led me here, and I could just traverse from one to the next without having to redo the stupid print statement every time I changed. So we moved from this get auto commit into an enter function, this dunder ender with enter. This is a special method that Python uses to create context managers, which are the power behind Python's with statement. In that particular function, I noticed that the only place that get auto commit is called is when the current connection is not inside an atomic block. But when the connection is in an atomic block, this particular function doesn't get called. Well, that must mean that my database is unexpectedly not in an atomic block. Well, OK, so what is an atomic block? An atomic block is, you know, fuck this. This code is way the hell down inside Django's internals, right? And I'm sorry, but if this was problematic, there would be screams of rage from across the internet about it, right? It cannot possibly be here. In fact, I have a statement for situations just like this one. So I went back to my stack, and I decided to move on to the next function above that one, which was the place where we entered into these atomics. And when I opened up that code, I noticed that we were iterating over database names in all of the names of the databases that you had. And this was when it occurred to me, hey, I have a primary database and a replica database. Maybe there's something going on with those two things. Let's print this DB name and find out. Awesome. I'm going to add a little print statement in here. I'm going to run my tests, and but then sometimes an intuitive leap happens, right? And lightning strikes, and you get an idea. But to be perfectly honest, intuition is a shitty word for what happens here, because it puts it on me and my skill level, right? I've got this deep insight. The problem is that that's not really true. The more familiar you are with the code that you're using, the more likely something like this is to happen. So the better you know your code, the more likely you are to remember things like this. What happened to me was that I remembered seeing DB name somewhere else in the prior days leading up to this particular day. Way back at the beginning of the bug hunt, in fact, back in that setup databases function. And if you look at the top here, you'll see that we're iterating over a dictionary that has database signatures pointing at tuples of DB names and aliases. So I thought, OK, I'll go there, and I'll print out the DB name. But I got the same result. So it wasn't the database names that were problematic. But when I looked on the next line, I realized that we were actually also iterating over all the aliases for my database. And maybe there's something actually in there. So let's print the alias. And this time, in successful runs, I see this. But in failed runs, this. This is the point at which realization hits. And I can tell by the room that most of you have already gotten the joke that's coming up here. When we iterate over these test databases, we're doing so in a dictionary that's keyed on signatures, right? And signatures are made by the settings that you have for the databases in your Django database settings dictionary, right? Those signatures, if you have the same parameters, lead to the same signature, and then all the names of your databases become aliases in that list of aliases. And what do we do with those aliases? Well, the first thing that we do is that we grab a connection by its alias. If it's the first time we've ever seen that alias, we go on and we create the test base using that connection, keyed by the alias. So when we create our test databases in Django, what we do is use the first alias that's listed. But when we run the tests, we always use the default alias. Now, if this were really a bug, right, it would have been fixed a long time ago. There would have been something else. Somebody else would have screamed about this years and years ago. It cannot possibly be that this is actually a bug, because it's so simple and so straightforward. Somebody must have written something down about this, and in fact, they did. It turns out that in my quick perusal of the documentation for Pytest Django, I glossed over the part where it says tests requiring multiple databases should go off and read the multi-DB support page in Django. I thought this time I should go back and read a little more carefully, and so I did. And when I opened it up, I found this section about testing with primary and replica configurations. And in there, I found a little line of code that was missing from my tests. And when I added that code to my settings, 3 days were fixed. Now, here's the thing, right? I could have put this on one line, but I felt so goddamned angry that I'd spent 3 days on this that I put the curly braces on different lines so that I could justify the time. All right. Now, I am a believer that we should always leave the world a better place than it was when we found it. And so what I did was I went back to Pytest Django's documentation and I opened a pull request. The reason that I missed this in the first place was because in my mind, multi-DB support meant using different databases for different areas of the code in order to keep them separated out from each other. It never occurred to me that primary and replica configurations could be another example of this same thing. So I wrote up a little bit, we went back and forth with the Pytest Django authors, and we added a couple of lines here that made explicit the difference between, or the addition of, this primary replica setup. And thanks to Blue Eyed, one of the maintainers for Pytest Django, that commit got merged, and that's now live documentation, and hopefully some other poor sap will not spend 3 days hunting down this particular bug. All right, there were a couple lessons that I learned as a result of this. Print works, logging is powerful, getting context can help you figure out a new path from where you are, and where the bug is seen is almost never where it actually showed up. Finally, trust your instincts, and when you're down inside transaction code, get the hell out. And always, always, always read the manual. Thanks very much.